Okay, so there are going to be some problems in your notes where we're going to basically take these proportion concepts and apply them. And so the first one is this one, which is what I said we were going to look at, where we have a proportion. If x is to y, then 7 is to 11. And we're going to write two other equations that are equivalent to the fraction. Now, you could write up to 4. So I'm going to go ahead and write all 4, but you only need to pick 2. There is a problem like this on your homework 8.1, in which you're going to be asked to basically take a given proportion and then they're going to write a bunch of other proportions or other ideas that you have to tell if they are equal or not. Okay, so the first thing that we can do is we could, of course, cross multiply and set up an equation that's equal to this. So if I were to cross multiply the 11 and the x, I would get 11x equals, and then I cross multiply the 7 and the y, I would get 7y. And this would be an equation that is equal to this proportion because I'm using cross multiplying. Okay, now let's go ahead and let's rearrange where I'm placing the values. At all times, though, we have to remember that the x and the 11 have to be across from each other, and the y and the 7 have to be across from each other. So no matter how I rearrange them, that has to be the same. Okay, so let's do the one where we flip each side then. So let's flip the x and the y and write it as y over x. And then we'll flip the right side so we can keep the 11 diagonal from the x, 11 over 7. So that would be another example of an equation or a setup for that proportion that is equal. Okay, let's do another one. So let's keep the x here, and let's put the 7 underneath of it. So if I want to keep that consistent, then I need to make sure that 11 is on the bottom of the other side, okay, because it still needs to be across from the x, and the y is on the top. So I'm going to put the y over here and the 11 over here. Again, you're looking to see if the cross products are the same. If they are, then you know that you've got the right setup. And then I'll do one more like the addition one that we saw. So again, I can add the top and bottom of the proportion, x plus y, and write that over the denominator, which is just y. And then over here, if I did that, if I add the 7 and the 11, that's going to actually give me 18, and then I'll keep the 11 in the denominator. So again, those are just basically restating what we did over here on this page, just using some real values that they plugged in for us here. So the second part of this is for us to actually solve proportions. When a value is missing, we can find the missing value. And we can do that by using the idea of cross products. If it is a proportion, then cross products should be equal. So therefore, I'm going to set these up by cross multiplying and then solving an equation to finish finding the variable. So for this one here, 5 is to z as 20 is to 3. It does not matter where I begin my cross products. I always begin my cross products wherever my variable is, if there's only one variable. So in this case, I'm going to do the z times the 20 and write 20z. And then 5 times the 3 is 15. And then from here, to solve this equation, I just simply divide by 20. And I'm going to put a little thing on there so it looks like a z, because my 2's looks like z's. So if I put a z there, 15 divided by 20 can simplify into 3/4 or 0.75. If it does not come out to be a nice fraction, you're going to want to leave it as a, if it does not come out to be a nice decimal, then you're going to want to leave it as a fraction. So if it comes out to be like a repeating decimal of any sort, then don't write it in decimal form, leave it as fraction form. I would say to go ahead and leave it as fraction form in general, because that's just the safest bet. Okay, now over here on this proportion, you'll notice that there are 2 variables, but that's still okay because we're still going to apply our knowledge of cross multiplying with proportions. Be very careful when you multiply 6 times this though. This is a binomial. So when you multiply it, it needs to be inside parentheses because it's going to need to multiply with both. Okay? So you're going to want to make sure that when you have anything where the denominator or the numerator has 2 things in it, that you keep it inside parentheses. So that means I'm going to need to distribute this. Okay? So that's going to give me 18n equals 6n plus 36. And then I need to get the n's on the same side, so I'm going to subtract 6n. That gives me 2n equals 36. And then divide by 2, and I get that n equals, oops, sorry, goofed, 12, not 6, or not 2, I mean. Divide by 12, and that means n equals 3. So you should have already done this many times when you were first learning these. At the very latest, you probably learned these in pre-algebra, knowing how to solve proportions. In some instances, you might have done it in Algebra 1 and also even earlier than pre-algebra. But this is how we set up proportions to solve.